everyone! Today we're going to talk about the Fibonacci sequence. We're going to solve the Fibonacci sequence recursively. So what is the Fibonacci sequence? Basically, it's the sum of two numbers, the sum of the two preceding numbers. So for example, you have 0 plus 1. So 1 plus 1, 2, 1 plus 2, 3, 2 plus, that doesn't look like a 3. 2 plus 3, 5. 5 plus 3, 8. So the Fibonacci, zero starts from 0. 1, 2, 3, 4, 5, 6. So the Fibonacci of 0 is 0, Fibonacci of 1 is 1, Fibonacci of 2 is 1, Fibonacci of 3 is 2, Fibonacci of 4 is 3, Fibonacci of 5 is 5, Fibonacci of 6 is 8. Today we're going to be solving to get the Fibonacci number of 6. So, all right. And And on the right side, you can see that we have the Fibonacci sequence and our pseudocode. And if you look at it, we have, I'll quickly explain the pseudocode. If n is less than or equal to 1, we return it. And if not, we keep recursively calling in a tree. So we add fib of n take away 1 plus fib of n take away 2. We add these two recursive calls. And these two recursive calls are going to result in a tree. So today our goal is to trace tree recursion and learn how to trace tree recursion and how to do tree recursion. And you can say we're learning how to do tree recursion with return statements. All right, let's get into it. And we're going to have, let's do our function call here. Fib of 6. All right. I'm going to make our stack over here. And I'm going to put fib of 6 in our stack. And then I'm going to put fib of 5 in our stack. We do fib of 5, we call it. Fib of 4. Gets called into the stack. Fib of 3. Fib of 2. Okay, we put fib of 3. And fib of 2. All right. We reached fib of 1. All right. So what we usually do is we're going to pop fib of 1 out of the stack. I'm going to illustrate this only one time, but when we pop a function off the stack, we're going to erase it. Just want to show it. We pop it off, fib of 1 gets popped off. So fib of 1 gets popped off because if equals 1, we reach our base case. So this one here is 1. So we exit out of this function call. And let me just erase fib of 1. And then we make another function call here, fib of 1. So we put fib of 1 back in here. Oh, sorry, 0. When we're going from the left side. So sorry. N take away 2. 2 take away 2 is 0, so this one's here is 0. 1 plus 0 is 1. So now, sorry, I'm going to put in the back of the stack, I'm going to put 0 here. So we have 0 in the stack, and now we're going to pop 0 out off the stack. So now we're back at fib of 2. Now we're back here at fib of 2. All right, it looks like we have completed fib of 2. So now we're going to pop fib of 2 off the stack. We're at fib of 3. So 3 take away 2, 1. One. All right, and we would put 1 back into the stack. All right. So here, this one here is 1, and this here is 1. So we have 1. Now we're going to pop 1 off. And then we're back at a fib of 3. Fib of 3, 1 plus 1 from the calls. So let me just put here 1 plus 1. It adds these two up. So now we pop fib off 3 off the stack. We're now at fib of 4. All right. We're going to call, what's 4? 4 take away 2, so it's 2. All right. And 2 take away 2, sorry, 2 take away 1. Now we're going to just need a little bit more space. So we'll do it here. This one here is 1, and take away 1 is 1. So here this one's 1, and here this one is 0. It's somewhere from so what's 1 plus 0? 1. So fib of 4 is 3. So 2 plus 1 equals 3, because this is 1 plus 0. It's similar to the one on your left of the tree. All right. Then we go here. All right, fib of, so now we pop 4 off the stack. All right, fib of 5. So 5 take away 2 is fib of 3. All right. And then we need a little bit more space. So 3, so here, how we're going to do this, we'll just move it. All right, we'll just Hold up, just out of space here. Fib 5. Oh, I have to make sure that looks like a 5. Okay, that's good. Let's try moving it. Here. Fib. So we're going to do 3. 5 take away 2 is 3. All right. And then 2. And then fib of 1. 3 take away 2 is 1. So right now we pop. Sorry, we don't pop anything. So we have 1 and 1 here. 1 plus 1. This is, so fib of 3 is 2. So for 5, so you're going to add these two. You're going to add 3 plus 2. It is 5. Fib of 5 is 5. All right. 5 is now popped off the stack. Now we're going to do the right side. 6 take, so this will be, let's actually see if I can move the pseudocode. Yep, I can move the pseudocode. Just gonna the sequence. Just move the sequence. You get the point, so I'm just gonna delete that. The pseudocode is over here. And see if I could move the stack. All right, we'll just work what we have for now. So we'll use yellow to represent the left side. It is 6 take away 2 is 4. Okay. And then fib of hold up, just to see if I can move the stack. I just want to move the stack. Where? Oh, here. Just want to move it. Just want to move it. I just want to move it. Here. Oh, silly me. Oh, yeah, I can move it. Okay, here. That's how you do it. Oops. All right, we'll just do the stack here. So, sorry about that. So, minus fib is 3. All right. Two. 1, 0, 1 plus 0. Oh, sorry, we forgot to do it. This our stack calls. So fib of 4, fib of 3, 2, fib of 1, fib of 0. All right. So 1 and 0, if you look at over there, we pop those two off the stack. Go back to 2. 2 has been solved. So 2 is 1. And returns. So 2 has been called. And then you go fib of 1. 3 take away 2 is 1. So therefore 1. So this here is 2. Now we're going to go on to, we're going to go over here and we're going to do the right side. Okay, fib is 2. So back at fib 4. So fib is 2. Fib is 1. Fib is 0. 1, 0. So fib 2 is 1. So 4, so quickly we pop all of these off the stack. It's been solved. And we're at fib 4. Let's just put fib 4 back in here. Fib of 4. Fib of 4 is, so 2 plus 1 is 3. 5 plus 3 is 8. And we pop everything off the stack. We're done the recursive call for the function. And 6 is 8. And the time complexity for solving this recursively, Fibonacci numbers, is n of 2. All right, thank you for watching, and I hope you guys have a great day.